Hi everyone, I hope you're all doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 2 for the Northern Hemisphere Extended Response question. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah guys, let's smash through this video. Question 1. Consider the function f with this rule. Okay, sketch a graph of f over its maximal domain on the set of axes below. Label the endpoints with their coordinates. Very, very easy. Now, I just used your calculator to pretty much graph this. So let's do that. So it is 10 arc cos 2 minus 2x. Perfect. And what I'm going to do is I want to make sure the scales are the same. So what I can do is pretty much whatever I see on my cast, I can, draw on my paper. So for example, go on menu, go on Windows Zoom, and go to Windows settings. What can we see in our graph? Well, the x minimum is -2. Your x max, we can see is 2. Your scale goes by 0.2 for your x scale. And what about your y minimum? Well, 2, 4, 6, it goes by -6, we can say. Your y max goes to 36, and your x scale goes by 2. And here's a perfect drawing. And what I can do is, to make it look very, very similar to the paper, what I'm going to go is view, go to grid, and go to line grid. Aha, perfect. Every square, every scale of each square should be similar to the paper. And what I can do is just copy whatever is in my cast to the paper. And yeah, let's do that. So you can see that one of the points are going to be in third over here. And I'm just going to go over here and go to trace. I'm just going to trace it first. So what about if at 1 we get 15.7, so 2, 4, 6, 15.7, it's around here. We can say that's a point. And what about at like 3.5? No, 3.5 doesn't work. Oh, 1.5 actually. What about 1.5? Go to trace. 1.5. Okay, at 1.5 it's 31.4. So at 1.5, so here it is 30 around here. And perfect. Now the graph should look like this if I'm putting them all together. Something like this. Nicely. The endpoints, the way you can find the endpoints is, okay, what is the actual domain of the function? So domain of f1 of x, comma x actually. This is your domain. It's from half to 3/2. I'm just going to find the endpoints, like the coordinates of the y-axis, saying like f of 1 of half, which is 0, and f1 of 3/2. Here are our endpoints from 0 to 10 pi. Let's do that. So this coordinate here would be half. Well, it's very... I'm going to make this smaller. Here we go. So this will be half 0. And this coordinate here would be 3/2 to 10 pi. Nice. Pretty much, yeah, these are your endpoints. That should give you 3 marks. Easy. A vase is to be modeled by rotating the graph of f about the y-axis to form a solid revolution where units of measurement are in centimeters. Write down a definite integral in terms of y that gives the volume of the vase. Okay, so what's happening is that imagine just drawing the reflection of it around the y-axis and imagine rotating it along the y-axis. We'll get something like a vase pretty much. As you can see, if you rotate it, we'll get something like a vase. That's what they're telling us, and we want to find that volume of that vase. Easy. First, what you're going to have to write is volume is just pi integral. Well, because we want to rotate it along the y-axis, about the y-axis, these values here must be y's. So we're going to write dy. dy means that you're rotating it about the y-axis, and your values here should be in terms of y. Well, if we're looking at our graph, we're going from 0 to 10 pi. Those are your coordinates. So write those down. So 0 to 10 pi, your y coordinates. And inside it must be x squared. What is the x squared of the function? Well, in our case, if we have f of x, we can say as y equals 10 I want to write it as cos inverse of 2 minus 2x. We can just solve for x. So it'll be y over 10 cos 2 minus 2x. Hence 2x is just going to be 2 minus cos y over 10. And then dividing it all by 2, we get 2 minus cos y over 10 all over 2. Pretty much that. And imagine x squared. We want x squared, so we're squaring the whole thing. We're just going to get 2 minus cos y over 10 all squared over 4. And that's going to be x squared. And imagine writing this inside our integral, and that's going to be our definite integral. So let's make it bigger. So we're writing 2 minus cos y over 10 squared all over 4. And that's it. That should give you the mark, but also I'm just going to pretty much make this little, and I'm going to put it, because this is also essential working out how we got our x squared. So yeah, that's it pretty much for that question. Just take this and put it over here. Nice. That is your solution. This is your solution for that question. All right, next question. Find the volume of the vase in cubic meters. Okay, very easy. Just evaluate it. Let's use our CAS. So we're saying pi times the integral from 0 to 10 pi of the function 2 minus cos y over 10 all squared divided by 4 in terms of y, and we get 45 pi squared over 4. Let's write that down. So hence your volume, it's just going to be 45 pi squared all over 4. And that's it. Make this a little smaller. There we go. Nice and easy. Next question. Water is being poured into a vase at a rate of 20 centimeters cubed. Seconds, -1. Find the rate. So we want the rate in centimeters per second. Centimeters per second. Okay. At which the depth of the water is changing when the depth is 5. Okay. So okay, let's understand this. We know water is being poured at a vase at 20. So we know, look, just having a look at the units, this here is volume and this is time, and it's a rate. So it's going to be d volume d dt, which is time. So this is the rate of the volume over time, as you see, and that's 20, and it's going to be positive 20 because it's being poured into the vase. It's a rate that is positive. So we have that. That's great. And what we want to find is centimeters per second. Find the rate in centimeters per second. Centimeters is like height, how the height changes. Well, our height in this case is y, our y coordinates, as you can see. So it's going to be, we want to find dy, dt per second, at the depth of 5, where y is equal to 5 pi. That's what we want. And we want to evaluate that. Okay. So to get dy dt, let's think. To get dy dt, we need to find something that has dy dv multiplied by dv dt. And why do I write it like this? Because pretty much this is equal to this, because the dv's actually cancel out and we just get dy dt. I wrote this because I know this expression is 20 and I just need to find dy dv. And that's also easy because we do have this over here that gives us the volume in terms of y. So if I'm actually, okay, writing this, let's go to our CAS. And we have this. This is going to give us our volume. Volume, like V, it's pretty much, let's write it. V equals, so your volume is equal to this. But we're not going to 10 pi. Remember, it's going to have to be y, where y is the height. And because we need an expression. remember. So if we enter and we get this beautiful expression, so your volume is actually equal to this. But remember, what we want is dy dv. So first let's find dv dy. To find it, we just need to find the derivative in terms of y. Find the expression of this. And now we got dv dy. Now we need to find dy dv, which is the reciprocal. So it will be 1 over this whole expression. And it gives us this expression right over here. That's it. Let's write that down. So what we just did. So what we did was, okay, we found out that the volume is equal, so its volume is equal to pi integral from 0 to y, whatever I did in my CAS, of 2 minus cos y over 10 squared all over 4 dy. Remember, we are going through y, where y is the height. So it could be, you know, the height from the vase could be changing over here. It could be over here. So that's why we write y, because we want it in terms of y. So pi, yep, so that. And that's going to give me the volume. And that's equal to an expression. That's very ugly. I don't think writing it would be a great thing. So I'm not going to write that down, actually. And then what I want to find is, okay, actually, let's write that down. Okay, so it's just pi 5 sine y over 5 minus 80 sine, okay, it's too little limited space. So what I'm going to do is I'm going to take this, make this little. That's equal to this over here, so sine y over 10 plus 9y all divided by 8. That's the expression. Great. And what we just found was the derivative of this whole expression. Remember, so our derivative, so dv dy is, let's go to, so it was, when we did that, it's just equal to pi. Let's write that down. So pi cos y over 5 minus 8 cos y over 10 plus 9 all divided by 8. That's it. So we got dv dy, and what we want to do is reciprocate it so we can get dy dv, which is just, imagine reciprocating this whole thing, it's just going to be 8 over pi cos y over 5 minus 8 cos y over 10 plus 9. There we go, and that's nice. So we've got dy dv, and we just need to multiply it by dv dt, which in this case is 20, and we then get dy dt. So imagine multiplying this by 20. So let's go to in our CAS, and so what we're saying is we take this, and hence we just multiply it by 20. We get 160, pretty much the same thing. Just, yeah, 160 over here. Put 160 here. And pretty much that is it. And now, remember, we want to evaluate it where y is equal to 5 pi. So, given that as y is equal to 5 pi, what do we get? Dy dv is what? So take this, and we want, when y is equal to 5 pi, we get 20 over pi. So that is your rate, 20 over pi. Nice and easy. I know I'm going very slow, but I want to show you the steps, pretty much. I just want to, if you guys get confused, I just want to slowly go through the steps to help you guys understand what the instructions are and how to smash an equation like this. There we go. Nice and easy. Next question, D. The vase is placed on a table. A bee climbs from the bottom of the outside of the vase to the top of the vase. Okay. What is the minimum distance the bee will need to travel? Give your answer in centimeters, correct to one. It's only 1 mark, so we don't actually need a lot of working out. That's great. So he starts at the bottom of the vase. He starts at this bottom. And he climbs up to the top of the vase. And what is this distance, pretty much? What is this? Well, that's the arc length, isn't it? Let's just find the arc length. So if we find the arc length, so we know that length, your arc length, is going to be the integral. Well, we'll get in terms of x. In terms of x, because we want to use the original function. Let's get it in terms of x. So in terms of x, we're going from half to 3 on 2. So let's write that down. Half to 3 on 2. So half to 3 on 2. And we know the formula is, if you don't know, it's just 1 plus f dash of x squared, all squared, pretty much, dx. That is the formula. So, okay, let's go to our calculator. We know that f1 of x is our function. If you come here, it's this function over here. That's what our f1 of x is. Now, what we want to do is we want to find the derivative of f1 of x, which gives us this. And we also want to square it. So, answer being squared. Perfect, we get this. And we also want to add 1. So if we add 1, and overall square it again. Enter, and we get this expression. Pretty much that's it. We've just got the expression using our CAS. So let's write down, which is just equal to the integral from a half to 3 on 2, the integral of 4x squared minus 8x minus 397 all over 4x squared minus 8x plus 3 dx. And hence your length is what? So let's evaluate that. So from 1 over 2 to 3 over 2 over this expression dx, we get, control enter, we get 31 to 1 decimal point, so 31.4. 31.4. And that's it in centimeters. I know I'm pretty much, it's only 1 mark, so you just have to give your answer, but I want to show you how I use the formula. And yeah, I want to make sure I take my time showing you guys how to do the question. Yeah, a lot of students get messed up by, if you use a CAS calculator quickly, yeah, without understanding. I just want to, show you how I'm just pretty much detailing everything to show you guys how to do the question. So yeah, so let's go to the next question. Question 2. In the complex plane, L is a line given by this, okay? Show that the Cartesian equation of L is given by this. Okay, there's actually 2 ways you can do this. There is the perpendicular bisector or the actual normal way. For example, let's do the normal way. A lot of students know. What we just do is we let Z equal X plus YI. Actually, let me rub this and just do the whole thing. Yeah. Let Z equal X plus YI. And what we do is we sub it into this function. So, to this actual complex plane. So, we get complex X plus YI plus 1 is equal to complex X plus YI plus half minus root 3 over 2 I. Okay? And we can put some terms together. So, like X plus 1 plus YI. X plus a half plus y minus root 3 over 2 I. Done. And what we do is, because it's the absolute value, to get rid of those absolute value, it's just the square root of x plus 1 squared plus y squared is equal to the square root of x plus 1 half squared plus y minus root 3 over 2 squared. And what we can do is we can get, because they both have, square root, we can actually get rid of it by squaring both sides. So it will just give us x plus 1 squared plus y squared is equal to x plus a half squared plus y minus root 3 over 2 squared. Okay? I want to make this little pretty much smaller. Like this. Okay? And let's just continue doing this question. What we can do then is expand those. Let's expand those. So the x plus 1 squared is just going to be x squared plus 2x plus 1 plus y squared. X plus half squared is just going to be x squared. 2 times half pretty much plus x plus 1 over 4, yes, plus y squared, so negative 2y root 3 on 2 is what? Cancel those 2, minus root 3y pretty much, minus root 3y plus 3 over 4. And cancel things that we don't need. For example, x squared on both sides will cancel out. The y squareds also cancel out. Bring everything to the left. So 2x plus 1 minus x. I mean, these can add up to just equal to 1 and then pretty much minus 1. Bring on the left. Those cancel. We can get those out. And then plus root 3y is equal to 0. Okay. Now I can make this a little smaller too to fit that in. We are nearly done. And then you have this expression, and then we just solve for y. Then this becomes x, those ones cancel out, plus root 3y equals 0. Hence, we can say y is going to, if we bring the negative x, it will be negative x over root 3, as we expect to be that answer. Done. That is the actual normal way a lot of students do it, and yeah, it's very easy. But it's always good to know a lot of ways to do questions, because it can quite help you sometimes. It will help you, if you get stuck. For example, here is what we call the perpendicular bisector method. A lot of teachers don't teach it, so yeah, it's kind of not known a lot, so let's do it together. What is the perpendicular bisector is, okay, let's think about these points over here. This point over here is what? It's actually just negative 1, 0. Remember, it's like when you have a, say, z plus x plus yi, the coordinates, that point that this lies, so for example, is just negative x minus y. As you can see, so what it is the one that's doesn't have I. It's going to be, and just imagine the negative of it. So it'll be negative x, and the one that has the I, it's the y coordinate, and it's just going to be negative y. And that's what I just did over here. This one doesn't here. What about this one over here? And this point is negative half root 3 over 2. Let me write them on top actually. So negative 1 on 0. This one is negative half root 3 over 2. That's it. Okay. So what is the perpendicular bisector is that if we plot these 2 points, say this point, negative 1, this point here is, negative 1, 0. And let's say this point over here is negative half root 3 over 2. Let's say those are the points. Now the distance between them, imagine, this is like a line between them. The line that runs perpendicular to, in the midpoint, so the midpoint of the line that passes through that line to the inside the midpoint is the actual equation of this line. Pretty much, it's the equation of this. And how do we do that? Well, let's find the midpoint. Well, the midpoint's very easy. You add the x values, this one divided by 2. You add the y values and divide them by 2. For example, let's add those. So it'd be negative 1 over 2 plus 0, which is that, and divided by 2, which is times a half. It's going to be negative 1 over 4. So negative 1 over 4. And the same for the y values. So root 3 over 2. Add it with... Oh, no. What am I doing? Sorry. I actually added the wrong things. The x value is, so negative half plus, which is just minus 1, divided by 2. So that would be negative 3 over 2, pretty much times a half, which is negative 3 over 4. That is your x value. And what about your, let me rub those off. What about your y value? Just add, it's pretty much add them together and divide them by half. It's just root 3 over 4. This is this midpoint over here. Done, we have a midpoint. And what about the gradient? Because if we can find the gradient and we have a point on the graph, we can actually find the equation very easily. Well, the gradient is, we have those 2 points. So we can find the gradient of this line and imagine the perpendicular gradient. So your normal line, it's going to be the gradient of this. So let's do that. So it's going to be your root 3 over 2 minus 0. Negative 1 over 2, negative half minus 1, so minus pretty much plus 1. So this gives us root 3 over 2. Well, over half, so negative 3 over 2, divided by half, which is just times 2 over 1, which is root 3. Okay, and imagine finding the perpendicular gradient of it, so it's just going to be negative 1 over root 3. Done. So the gradient of this line is negative 1 over root 3. How easy is this now? We have the gradient of the line, and we also have a point on the line. So now we just use, y minus y1, the equation to find an equation of the line. So y minus, well, the y value is root 3 over 4, is equal to the gradient, x minus, which is just plus 3 over 4. And we just simplify to get the y value. So your y is equal to negative 1 over root 3 of x, negative 3 over 4 root 3, then plus root 3 over 4. Simplifying this much further of x. Rationalizing this, we get negative 3 root 3, 4 at 12, so 12, and we can just say this can be 4, and this would be root 3, plus root 3 over 4. Now both of these cancel out, and we just get the equation of the line. Done. That is also another way. We use the perpendicular bisector. Look, both ways are great. I think normally for this kind of question, it's very, very long to do this. I'm going to be honest. Using the perpendicular bisector, I want to show you visually how to do it, but you can do it easily. Like find the point, find the point in the midpoint, so just find the midpoint of them, and just find the gradient using the perpendicular, the normal line of it, and then make the equation. You can smash the equation quite fast. Now let's do B. So find the points of intersection of L and the graph of this in Cartesian form. Okay, so let's find the equation of this. So if we let z equal x plus yi, so we're saying x plus yi multiplied by x minus y, the conjugate, equals 4. Now I'm just going to do this on my calculator. I'll be honest, expand it. So for example, this over here, I'm going to write it as z times the con of z, and that all should equal to 4. And I want to say, given that z is equal to x plus yi. Enter, and we get this. It's just the equation of a circle. Let's write that down. This pretty much, this whole thing just simplifies. X squared plus y squared equals 4. And we know that the line L is what? The line L is, this is the equation, so it's just y equals negative 1 over root 3x. We just did that. And okay, let's find the point of intersection. So imagine subbing this, the y value, into this. So it's going to be x squared. Imagine y squared. So it will be x squared over 3 equals 4. So it's 1 plus 1 over 3, which this here is 4x squared over 3 equals 4. Okay? And both sides have 4, so we can cancel those out. Put that 1 there. Hence x squared is equal to 3. Hence x is just plus or negative root 3. Great, we have 2. And then, okay, take the case that we have root 3. Let's find the coordinates of root 3. So going back to this equation, to find the y coordinate, so it will be negative, what's the x value? Let's take the positive x value, so root 3 over root 3. It will be negative 1. When x is positive root 3. Hence, one of your coordinate would be root 3, negative 1. For the next one, if we put, what about if we put negative root 3? So it'll pretty much become y equals 1, actually. So when x is equal to negative root 3, hence your other one is negative root 3, 1. These are your points of intersection. Easy. You can also do this like in a second in your calculator, but yeah, this is how you do it by hand. So, done. Sketch the L and the graph of the relation this on the Argand diagram. Easy. So let's do that. Well, we know it's a circle. This circle that has what? We see the center point 0, 0, and it has a radius of 2. So let's draw that. Here, 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 and here. Imagine just drawing a circle with a radius of 2. Wow, what was that? Let's do it again. There we go, nice. And let me kind of, so it's like that. And we've drawn that, and we need to draw the line L. Okay. All right, so the line L is just y equals -1 over root 3x. Well, let's just find the angle. For example, if we have this equation, to find the angle, you know how it's normally the tan. So this, your angle is just tan inverse of the gradient. So that's what I'm going to do. Well, the gradient is just -1 over root 3. Tan inverse of -1 over root 3 is just -pi over 6. So that pretty much is a line that passes through the center, we know. And and it has an angle of like -30, so right over here. The line pretty much passes through here. Where this here is -30. This angle here is -pi over 6. So that's it. We can draw that. So that's line L. And the other one here is just, the blue line is just x squared plus y squared equals 4. Easy 2 marks. Next question. The part of the line in the fourth quadrant, so here in this fourth quadrant, can be expressed in the form of argument z equals alpha. State the value of alpha. Easy. Easy. Well, this is, what is the, we have the line L, and the angle is this, isn't it? And we already did find that angle. We said it was -pi over 6. So that's your actually alpha value. Your alpha value is just -pi over 6. If you draw a ray, so remember a ray, it starts at 0, 0 in this case, and it passes this, well, the ray would be here, would be -pi on 6. We just calculated that. Done. Okay, -pi over 6. Easy. Let me write that nicely, actually. -pi on 6. Find the area enclosed by the line L. Okay. And the graph of the relation this, so the circle, and argument z equals pi over 3. So what's that? Well, so argument z, so it starts at 0, the ray. Pi over 3 is 60 degrees, so it's over here. Let me actually draw a different color, red. This is just your, okay. I'm gonna rub this actually, the small part here, I don't need that. And where, remember, relative z is just x, so x equals root 3, which is over here. That one passes over this point and this point, so drawing a straight line, we get this. So the area enclosed by all of those is this area over pretty much this area over here. This is the area that we want. That's the area. Okay. How do we do that? So let's actually draw that area. Like, let's just draw it over here. How does it look? It looks like a sector, like this. And there's a line that passes through it. So from here to here, and this line, this is passing through it. And we want to find wait, actually, that's not the best way. It's actually like this, actually. It looks like this. So the parts here, actually, that's actually very hard to draw in a way, because if you have, it actually looks like this then. Am I drawing this? Okay, so it looks like this, and we want to find this area. Well, okay, it's actually quite easy to do that, because if we can find the area of a sector, which is this whole area, and then minus this area over here, we actually get this area. Why don't we do that? So, for example, let's find the overall sector, the area of a sector, and you should have these formulas in your formula sheet. So not formula sheet, but you should have those in your bound reference. To find the area of a sector, so the area of a sector is half r squared theta, where theta is this over here, and your r is your radius of this. So in our case, if you're at half, what is our radius? Well, this is our radius, which is just 2. So we can say 2 squared. And what is our theta? This over here. Well, it's easy because we know that, if I go over here and quite rub this out. Okay, we know that each of these lines over here is 30 degrees, which is pi over 6. And if this is 30 degrees plus 30 degrees, which is 60, and plus another 30, that's 90 degrees. And hence it's a right angled triangle, which is true. Like if you draw, it is a right angled triangle. So it's 90 degrees, so which is pi over 2. Okay, and then simplifying this, we get, okay, what do we get? We get 2 pi over 2, which is just pi. Hence, the area of that sector is just pi. That's good. Let's keep that. So the area of the sector is just pi. Let's write that down. So that's good. So we found the area of this whole sector. And now let's find the area of the segment of this. Okay. Remember how the area of a segment? So let's write area of a segment. Formula is half r squared theta minus sine theta. That. So in this case, have a look. So r is the radius. Again, the radius is the same. If you come over here, we want this segment. So which is, in this case, this is your theta, and this is your radius, which is still 2. But your theta now is 60 degrees, which is pi on 3. This is how it looks. So you draw this like this. We know still the radius is the same in our case, in this one. And we know now this angle here is pi over 3. Let's I don't need this actually. Let me draw up this. It's, yeah. So we can say half, your radius is 2, so 2 squared. Theta is pi over 3 minus sine pi over 3. So that's going to be 2 pi over 3. So sine pi over 3 is minus root 3 over 2. Is that right? Yep. And then it's going to be 2 pi on 3 minus root 3. That's it. Now, we know that area of the segment, and just we say the area of sector, so pi minus this overall, and we get that area. So, area is just pi minus this overall expression, which is just going to be 2 pi on 3 plus root 3, which is what? That's going to be pi on 3. It's got 3, yep. Okay, plus root 3. This overall is your area. And that's it. I hope that's easy to follow. Well, let me just... Actually, that's not that's ugly color, so let's do this, yeah. Nice. I hope you understood that. The straight line L can be written in the form as Z equals K conjugate Z, where K is an element of a complex. So, okay, find K in the form of r cis theta, where theta is the principal argument of K. Okay, so, okay, let's actually let Z, so in this case, let Z equal x plus y. Let's do that. So it's just going to be x plus y, where K is what we don't know, and the conjugate is just going to be x minus y. We get this. And what do we do? Well, let's do this in our calculator, because I feel like 2 marks, we can do a lot of the information in our calculator. So, so what we said is, so Z is equal to K times the conjugate of Z, which is, we want also that Z to be x plus yi. enter, and we get this expression. Now, what we want to do is think about it. Okay, we get this, and if we solve, so if we solve for y, comma y, actually not y, actually that's not a good way, yeah. If we solve for k, what's happening? No, we solve for y, wait, we solve for y, because what we want to do is, if we solve for, and we write complex solve. Oh yeah, I forgot to write complex solve, because we know that it's gonna have some i's. We get this expression. So this is our equation of the line. So let's write that down. So this whole thing, y equals negative k minus 1 xi all over k plus 1. This expression should equal, remember this whole expression, y equals, should equal y equals our line root 3. Remember, it's like y is equal to this, and now we've got y equal to this. So what we can do is we can equate them, pretty much. Let's equate them. So negative k minus 1 xi k plus 1 is, we equate it to this. We use our calculator to calculate the values of k in this expression. So let's do that. So we have this over here should equal to negative x root 3. And we get this, and we want to solve answer, comma k. Make sure you write complex solve, actually complex solve. And we get our value of k. Nice. But we want it in terms of our cis theta. We want it in polar form. That's easy. We just go to menu, go to number, complex number 2, and we want to convert to polar. Enter, and it's given here. So your radius is 1, and your angle is negative pi on 3. Forget the I, just negative pi on 3. Let's write that down. Your k value is just going to be cis negative pi on 3. Done. Question 3. A 2 kilogram crate rests on a smooth plane inclined at theta to the horizontal. An external force of F newtons acts up the plane parallel to the plane to keep the crate in equilibrium. So if it's in equilibrium, we know the acceleration is 0. On the diagram below, try and label all the forces acting on this crate. Okay, so what we're going to have, of course, we're going to have force of gravity. Well, the mass is 200, so it'll be 200 g. We're also going to have a normal reaction force. That's acting up the plane, so, perpendicular to the plane. That's going to be n. And remember, it says that F acts parallel to the plane and up the plane, so it's going to be like over here. And that is the value of F. So have we forgot anything? External force acting on the plane parallel to this. On the diagram, draw all the forces. Yeah, those are only your forces. Hence, find F in terms of theta. Okay, what we can do is, okay, if we equate this, so we know that if we find the components of this, where this is your theta here, hence this over here is going to be a vector on the left, so the force on the left. So let's say it accelerates down. Let's say it's accelerating down. Let's say it's accelerating down. Using your force equals mass times acceleration, what is the net force? Your fatness, because we're taking down as positive, because acceleration is positive, we're going to have to take 200 g sine theta. Remember, it's this over here. This vector over here is 200 g sine theta. And we're going to minus f. And that's equal to your mass times your acceleration. Well, our acceleration in this case is 0. So this overall is 0. Hence, your force, your F in terms of theta, is just going to be 200 g sine theta. And that's it. The magnitude of the external force is changed to 780 newtons, and the plane is inclined at 30 degrees. Taking the direction down to the plane to be positive, find the acceleration of the crate. So again, same case, acceleration is down, but now we have the forces, like we have force is changed to 780, and that's that. Now we have acceleration. Same thing, so it's going to be 200 g sine. Now, because we know the theta is 30, we're going to put 30, minus your f, which in this case, we're saying it's 780, times equals your mass times your acceleration. And we want to find that acceleration. All right, so this would be 200g. Sine 30 is just sine pi over 6, which is a half. So we can write it as 100g. 100g minus 780 equals 200a. And what do we do here? We know that g is 9.8, so we're saying 100 times 9.8, it's 980. So this is just 980 minus 780 equals 200a, which is 200 equals 200a, hence acceleration is 1 meters per second. Done. Oh, so squared. Easy. Great. Next question. On the axis below, sketch the velocity time graph for the crate in the positive direction for the first 4 seconds of its motion. Okay. Now we know that this is a velocity time graph, and we know that the gradient of a velocity time graph is the acceleration. Because we're taking acceleration is going to be constant, actually, in this case. There's no friction, so it's going to be a nice constant acceleration. So if the acceleration is constant, hence your velocity is just the integral of your acceleration in terms of time. Well, in this case, it's 1 dt, which is t plus c. So your velocity is equal to t plus c. Now c is, okay, do we have a condition? Well, we know already initially it's at rest. So at time equals 0, the velocity is 0. Hence, your c value is just 0. Your velocity is equal to t. So it's like y equals x. Pretty much. It's just a straight line. So let's do that. So it's a straight line for the 4 seconds, so it is, and it's going to pass through those. Remember, you be careful, you don't want to put here, because remember, time is never negative, it's always greater than or equal to 0. So that's easy. Calculate the distance the crate travels in meters for the first 4 seconds of its motion. Okay, if we have a velocity time graph, especially for the 4 seconds of its motion, the area under the graph is the distance. So we just need to find this area. Easy, it's a triangle, so it's going to be area, or your distance, is half for this over here, and what's the height? It's 4. Which is what? It's just 8 meters, pretty much. That's it. Is that right? Yes. Starting from rest, the crate slides down a smooth inclined plane at alpha degrees to the horizontal. Okay. A force of 295 cos alpha newtons acts up the plane and parallel to the plane. So, in this case, what's happened is, okay, this force over here is now, what is it? 295 cos alpha. So, 295 cos alpha, that's acting up the plane. What else? Starts from rest, and now this angle here is alpha. Hence, this is here, it's alpha. Okay. If the momentum of the crate is 800 kilograms per meter per second, after having traveled 10 meters, find the acceleration in meters per second of the crate. So, okay, if we have the momentum, remember momentum P is just equal to mass times the velocity. So, if I know that the momentum is 800, and we know the mass of the crate is what? It's 200. We can find the velocity. Velocity, hence, it's just 4 meters per second. And we know already its initial velocity is u, equals 0 meters per second. And we also know that it's traveled 10 meters. So we know its displacement is 10 meters per second. And we want to find the acceleration. Remember, just using your Suva formula. So which formula we have used? For this one, we have VU, S, and A. We use V squared equals U squared plus 2AS. And we want to find, in this case, our acceleration. Is that the bit? Yeah. So your velocity, imagine 4 squared is 16. U is 0. So 2, what's your S value? 10. A. And 16, 20A. Your acceleration is 16 divided by 20. So like 8 over 10, 4 over 5. So it's just 4 over 5 meters per second. Meters squared per second. So that's pretty much it. Find the acceleration of the crate. That's it. Find the angle of inclination alpha of the plane if the acceleration of the crate down the plane is 0.75 meters per second. Give your answer in degrees. Okay, to 1 decimal place. Alright, so so it's still everything's the same. So what's going to happen? So if it's accelerating down, it's going to be again 200g sine alpha. So let's write down. So 200g sine alpha minus the force 295 cos alpha. Is that right? And that all should equal to your mass times your acceleration. Hence, our acceleration in this case is 0.75. Now we just calculate alpha. Let's do that using our CAS. So 200, 9.8, G is just 9.8, times sine alpha, which is, we call it A, minus 295 cos A is equal to 200, 0.75. And we just solve answer, comma A. Remember, A is our angle, and we know that the angle must be between 0 to pi over 2, 90 degrees. So, where A must be between pi over 2. So, from 0 to pi over 2. And we get this. And remember, this is in radians, and we want it degrees. Take this, times it by 180 over pi. So, 180 over pi, and we get 12 point this, which is, we want it to 1 decimal place, so 12.9 degrees. Alpha, it's 12.9 degrees. And yeah, that's that. So give your answer in degrees, correct to 1 decimal place. And we've done it nicely. Great. Next question. Question 4. A basketball player aims to throw a basketball through a ring, the center of which is a horizontal distance of 4.5 from the point of release of the ball and 3 meters above the floor level. The ball is released at a height of 1.75 meters above the floor level at an angle of projection of alpha to the horizontal and at a speed of v meters per second. Air resistance is assumed to be negligible. So what's this ball going to go? It's probably always going to go through projectile motion. So it's going to go like this, and it's going to be hitting the hoop. The position vector of the center of the ball at time t seconds for t is greater or equal to 0 relative to the point of release is given by this, where I is a unit vector in horizontal direction of motion and j is the unit vector vertically up. Displacement components are measured in meters. For the player's first shot at a goal, v is equal to 7 and alpha is equal to 45. Find the time in seconds taken for the ball to reach the maximum height. Give your answer in this form, where a and b and c are positive integers. So first, let's actually write this position vector in our calculator. I'm going to control N everything here. Okay. So I'm going to write R of t is this position vector. So it's going to be, so it's v. Well, our v in this case is 7 times t times cos alpha, which in this case is just 45 degrees, comma. Let me actually do this. That. Okay. The next one is v, which in this case is still 7, times t times sine alpha, which is still 45 degrees in this case, and minus 4.9 t squared. So we get this over here. Done. And anytime we get this expression, so, okay, let's think. If we want to find the time taken for the ball to reach the maximum height, give your answer in this form. Okay, where the maximum height is going to occur over here. This is your maximum height. Now, let's think. We know at the maximum height, the velocity, the vertical velocity, is equal to 0. Imagine that when the ball actually goes and when it pretty much hits the maximum height, it stops for a second and then goes down. So our vertical velocity for our maximum height is equal to, your vertical velocity should be equal to 0. So how do we do that? Well, if we have this position over here, what we can do is we find the derivative of it to get what we call the velocity, so r of t. Now this is our velocity expression over here, and what we said was the vertical velocity should equal to 0. So this here is your vertical velocity, and we know that should equal to 0. And hence we just solve answer comma t. And here is our time. Is it in the form of this? Find the time in second. Yes. So let's write that down. So first what we did, because it's 2 mark, what we've done is find r dot of t, which is the velocity, which is 7 root 2 over 2i plus 7 root 2 over 2 minus 49 t over 5. That's your j. And we said that the j component equals 0, so 7 root 2 over 2 minus 49 t over 5 should equal 0. Hence t is equal to 5 root 2 over 14, which is the same as our expression here. That's it. Find the maximum height in meters above the floor level, reached by the center of the ball. Okay, so look, what is this path? What we're drawing is, this is what the path is. The ball is starting over here. Imagine remember the guy's holding it, and this is the path that it's being sketched. It's going to go like this, and like this, and like this. Now, if we calculate that maximum height, we found the time at which it reaches the maximum height, it's actually going to give us this height to here. Remember? Because what we're thinking is we've thrown the ball from here. We've actually thrown the ball over here. So that value of t, if we find this height, we need to add it with this over here, which is that 1.75. And that is going to give us, because the question is telling us, the maximum height in meters above the floor level. Remember? So it's going to be this plus the 1.75. And that's going to give us our, Okay, nice and easy. So if we know our position, let's go on our calculator. If we know r of t is a position, and we know that the maximum height occurs at this value over here, so let's put that there. Done. This j vector, so your actual vertical distance, which is 5 over 4, we're going to have to add it with 1.75 to get the to get the height above the floor level. So 1.75, and it gives us 3. So it's just 3 meters. That's easy. So what we just did here, we found the position of 5 root 2 over 14, and that gave us the 5 over 2i plus 5 over 4j. Remember, this 5 over 2 is the horizontal distance. So here, it's pretty much gives us this distance from here to here, where the maximum, it's going to give us this. But remember, the j vector gives us from here to here. That's what we're going to add. So hence, 5 over 4 plus 1.75. That gave us 3 meters. Done. Easy. Next question. Find the distance of the center of the ball. Find the distance of the center of the ball from the center of the ring 1 second after the release. Give your answer in meters. So, okay. Let's have a look at this. So you know how the path is going for a path. Let's say it starts over here and it's going, and this now is 1 second. So the ball is actually over here now. And this is the center of the ring over here. And we want to calculate this distance, so like this straight line distance. To do that, how do we do that? Well, we need to find what is like the I and j. What is this position of this? Well, that's easy because relative to this, the ball starts over here. So what is its I vector? So it starts from here and it is over here, which is just 4.5. So this over here is just 4.5. We can write it as just 4.5i. And what about its j? It's going to be 3 minus 1.75. Remember, we're doing the relative to this. So it would be 3 minus 1.75. That is 1.25 plus 1.25 j. That is this position of this. Done. So, and we want to find the position at 1 second, so which is just r of 1. So what's r of 1 in our calculator? Oops, r of 1. And that it's this big vector over here, which we'll write it after when we do it. Yeah, so now we have r of 1. Now we have the position of this, position of this. Now we can just easily, you know, find the distance. It's just this minus this, and pretty much find the magnitude of that. And let's do it in our calculator. So what we do is, okay, we know that the vector at the center of the hoop is just 4.5, 1.25. Okay, so we know this is the r of 1 is the distance of that. So it's going to be this minus this over here. And we get this, and then we just need to find the norm, which is the distance. And we get, it's 1.28, that's the distance. So let's write that, what we just did here. So what we did was, we found r of 1, which was, I'll go up here, it is 7 root 2 over 2i plus 7 root 2 over 2 minus 49 over 10 j. And we know that the r of 1, actually the other one is just 4.5i, so 4.5i plus 1.25 j minus r of 1. Yep. And then we find the magnitude of that overall expression, and we get, what was it? We want it to 2 decimal places, so it will be 1.28 meters. That's the distance. Question B. For the player's second shot at goal, v equals 10, so the velocity is 10. Find the possible angles of the projection, alpha, for the center of the ball to pass through the center of the ring. Give your answer in degrees correct to 1 decimal place. Okay, so now, let's think about this now. What's happening? Why did I rub that out, actually? Keep the center of the hoop there. Okay, so what's happened is, okay, now he shot the ball. So now he shot the ball, and what we want to do is, this angle theta, it's going to be changing. Now, we want to find the angles at which, for example, he hits the projection, and it's going to go nicely past through the hoop. Or it could be some value over here that still pass through the hoop. You know, it could be many values. Well, so we want to find those angles at which they pass through the hoop. And we know with a velocity of 10, where he hits it with a velocity of 10, it says, yeah? Yeah. We want to find those angles. That's easy. Because if we know that it's going to go through a path like this, and it has to pass through this point over here. So what we're saying that, for example, r of t must equal, we must equal to this over here, 4.5i plus 1.25j. And we want to find that the time at it. Actually, we don't actually need to find the time. So let's think about it. If we use our CAS here, let's just try to do this. We're using our CAS. First, let's redefine r of t. So go up. R of t is this expression. Now, okay. Now, let's call it A, because we don't know now the angle. And now the velocity is 10 for both of them. Great. So this is our new path. So we know that r of t must equal 4.5, 1.25. That's what we said. And we actually get two equations. So what we can do is, okay, so what we can do is we can find those because we have two equations, we can find simultaneous equations, like algebra, solve system equations, and we have two, and we want to find alpha, the angle, and the t values also. So at which that occurs. So if I put this over here, now if I put this over here, and we know that the angle must be from 0 to pi over 2. Alpha must be from that. So pi over 2. Okay, Control Enter, and we get these values. Great. So how many values do we get? So we get 1, and we get 2. And both the values of t, so time is greater than 0. That's great. So we actually have two possible angles at which we hit. We have this over here. So let's convert it to degrees, which is this. And the next one is this, which is this. So let's write those angles. So let's write the steps that we did. So what we just did first was we said that we solved for r of t equals 4.5i plus 1.25j, and we solved two systems of equations. So we got 10 cos alpha t equals 9 over 2, the first equation. And we got the second equation, which is 10 sine alpha t minus 49t squared all over 10 equals 5 over 4. That's your second equation. And we solve those to get the angles, which are, your angle, first angle is 29 point to what? 1 decimal place, so 21.7 degrees, and your second alpha is 75.8 degrees. Okay, so that's pretty much it. Do we miss anything? No, I don't think we need those times, so those are the only two values. Great. So for the player's first shot at a shot, the angle of projection 60, find the speed required for the center of the ball to pass through the center of the ring, give your answer. So same thing pretty much. But now we're just changing our equation. So let's do that. So take this back equation. Now we know that the angle of projection is 60 degrees. Just change that up. 60 projection. And we know that this is velocity. We don't know the velocity. The right v, and okay, we got that. And same thing, r of t should equal what we did for the other one, which is this. We got this, and then we get two equations, and then we solve these two simultaneous equations, going to algebra, solve some equations, where we're calculating velocity and time. So the first equation is this, so let's write it down. And this is that. And, okay. Enter. Control Enter. And we get false. Why is that? What have we done? What if we write complex solve? Control Enter, and we get, okay, we get values from complex solve. So we get t equals negative. No, this is rubbish because time can never be negative, so this is rubbish. But this is true, where time, we can see that when t is equal to, because t is greater than 0 or equal, and then we get a velocity. So this is your velocity. I don't know why it didn't work with solve. We had to use complex solve here. Wow. Okay, so we get this value over here. So let's write that down. Our actual steps. So let's do some steps. So what we did was r of t must equal to 4.5 I plus 1.25 j. And so we got two equations from that. We got TV over 2 equals 9 over 2. That's your first equation. And we got our second equation, which was root 3 TV over 2 minus 49 t squared over 10 equals 5 over 4. That's the second equation. and we solve those to get your final velocity is only 7 point to what decimal place to 1, so 7.8 meters per second. Nicely and done. For the speed, find the angle. Yeah, just find the speed, correct to 1 decimal place. That's it. Question 5. A horizontal beam is supported at its endpoints, which are 2 meters apart. The deflection, y meters of the beam measured downwards at a distance of x meters from the support at the origin is given by this differential equation. Given that the both inclination, so dy dx, and the deflection, which is y, of the beam from the horizontal at x equals 0 are, so at x equals 2 are 0, use the differential equation above to show that ATY is equal to that. Okay, so let's do that. So this here, I'm going to divide, just want to get d squared dy dx squared. I'm going to divide both sides by 80, so it'll be just 3x minus 4 divided by 80. And we get this. So I'm going to integrate this. Now, the easiest thing is, okay, you know how when we integrate and then we have to plus c and then sub these values here? No, what we can do we can do it all at once. So what we can do is that we can integrate to find dy dx. How? So, well, we know that when x is equal to 2, so from when x is 2, so we write that when x is 2, y is equal to, dy dx is equal to 0. So let's write this here, 3x minus 4 over 80 dx. We know that your dy dx is equal to 0. We're going to plus 0 here. And we're just going to put an x here. We have to put x here. So what I just did, let me explain. So what I did was, if I know that, for example, if I know dy dx, yeah, and I'm integrating to get, y of x. And I already know a point of it, like y of 0 is equal to 2, let's say. So this, your x naught is 0, and y naught is 2. So I know an initial condition. So when I'm integrating this, you know how I'm going to get that plus c and then have to sub this to find that value of c? I can do it all at once. For example, if I know that x0, so x0 would be over here, you sub in x0 here, plus y0, and you're always subbing x here. This is an actual formula to do all the things at once. So using your CAS calculator. So that's what I've just done there. And yeah, let's do that. So let's get that. So use our calculator. So integral 2 to x 3x minus 4 80 dx plus 0. And we get this. So let's write that down. Hence your dy dx, so let's write that. Dy dx is equal to 3x squared minus 80x, so minus 8x actually, plus 4, all divided by 160. Now, y is just going to be the integral of 3x squared minus 8x plus 4, 160, dx. Again, using that initial condition, we know that when x is equal to 2 and y should equal to 0, so that's a plus 0 here, 2 and x. Let's do that. So hence y is going to be what? Alright, take this whole thing again, just pretty much change this to this. Anytime we get this, let's write that down. Like expand this, so x to the power 3 minus 4x squared plus 4x all divided by 160. Now, if we want to end this term, what's happened? Well, the y is just multiplied by 80. If I multiply both sides by 80, what do we get? So 80y, we just get x squared minus, so x to the power 3 minus 4x squared plus 4x all divided by 2, which is the same. I mean, yeah, they've just kind of more simplified it, so let's do that too. If I divide everything here by 2, we get, that's divided by 2. These just become -2, and this one becomes plus 2x, which is the same as that. Easy. All right, let's look at the next part. So it says, let me use yellow. Find the angle of inclination of the beam to the horizontal at the origin. Give your answer as a positive AQ angle in degrees. Correct one decimal place. So we want to find the angle of inclination. So we know inclination is dy dx. So if I can find dy dx, so if I find that dy at pretty much x is equal to 0, which is what? Let's use our calculator. So what is our dy dx? Our dy dx is this, and what is it when x, when x is equal to 0? We get 1 over 40. Let's write that down. And we want to find the angle, so of the inclination, which is going to be the tan inverse of 1 over 40. That is going to give us our angle. Hence our angle is what? Tan inverse of 1 over 40. And that's going to give us in radians, but we want it in degrees, so times 180 over pi. Try enter, and we get this. So to 1 decimal place, that's going to be 1.4 degrees, yeah. Pretty much that's it. So we found that. So that was 140, and then, okay, that's good. Find the value of x in meters where the maximum deflection occurs, and find the maximum deflection in meters. So the maximum deflection, okay. So what is deflection? So we said, they say that deflection is y. So if we want the maximum deflection, it occurs when dy dx is actually equal to 0. And we find that value of x, that's where the maximum deflection occurs. So if I know that this is dy dx and we want it to be actually equal to 0, and then we solve answer comma x, we get two values. We get 2 over 3 or x equals 2. Find the values of x. Actually, what I can do is, okay, let's think actually. Because we get 2, let's just be safe with it. If I know this is y, yeah? And normally to find the maximum value of y, what we do is we find the derivative of it. Well, I can just go calculus maximum of this function, comma x, comma where x is between 0 to 2. And okay, so the maximum occurs at 2 over 3. So at x equal 2, it's the minimum. So we need to be careful of that. So we found the value, 2 over 3. And we just need to sub in y of 2 on 3. So we found the value of the maximum. And we just need to find what's y 2 over 3. So which is what? So your y value, it's this. When is it? X equals 2 over 3. It's 1 over 135. Done. It's 3 marks, and I've just showed a little working out. So, just do something here. Because we've only showed a little bit working out. Let's actually put some working out here. So what we've done is hence 3x squared minus 8x plus 4 all divided by 160, and that's all equal to 0. And hence we can say x is equal to this. And then what we did is we subbed in what's y of 2 over 3, which is, we're saying that 2 over 3 squared minus 4 2 over 3 plus 4 all divided by 160. And that gives us 1 over 35. So the maximum deflection occurs over here. Nice and easy. Because we just do want to show some working out. It is 3 marks, so yeah. Next question. Find the maximum angle of inclination. Okay, inclination. So what is inclination? We said inclination has dy dx. So if we want the maximum, it's just finding d squared y dx squared when it's equal to 0. So find the maximum angle of inclination of the beam to the horizontal in the part of the beam where x is greater or equal to 1. Give your answer as a positive acute angle, correct to 1 decimal place. Okay, so again, what we're going to do is, when is dy d squared, the double derivative, which is this, equal to 0? solve answer comma x, and we get 4/3. So it will occur, so the maximum angle will occur, the maximum inclination will occur over here, and what I'm going to need is, what is this, so d squared dyx, given that x is equal to that, we get this. We just need to find the angle, which is just tan inverse of that. We want to turn it into degrees also, so 180 pi, which is this, but remember it's telling us to find a positive acute angle, so it's going to be just 0.5. So let's write all the things that we've done. So what we did was 3x minus 4/80. We let it equal to 0. Hence we got x 4/3. And I just said that dy dx, given that x at 4/3 should give us negative 1/20. And then what's, so find theta, tan inverse of negative 1/20 gives us negative 0.21 degrees, so it's negative 0.5, but we want the positive angle, so 0.5 positive, that's it. Degrees Celsius, so degrees, not Celsius, degrees, and that's it. Nice. Question 6. How many questions left? This is very long. 2 more. A coffee machine dispenses a coffee concentrate and hot water into a 200 milliliter cup water to produce a long black coffee. The volume of coffee concentrate dispensed varies normally with a mean of 40 and a standard deviation of 1.6. So that's the volume of coffee concentrate. Independent of the volume of coffee concentrate, the volume of water dispensed varies normally with a mean of this and a standard deviation of this. State the mean and the standard deviation in milliliters of the total volume of liquid dispensed to make a long black coffee. So to make an actual coffee, so coffee is what? If you're going to need water plus the coffee concentrate. Let's call, what do we call the coffee concentrate? Like a variable. Coffee concentrate. Let's call it F. Like the coffee concentrate. And what we want to find is we want to find the expected, so value of C. The coffee, the black, the cup of coffee. The volume of liquid coffee. Concentrate. So C, your to make a long black coffee. Okay, so this is your coffee. The normal coffee needs water and the coffee concentrate, which is F. That's what we've said. And we want to find the mean, so the expected value of C, which is the expected value of W, plus the expected value of F, which is what? We know that the expected value of water is what? The volume of water dispensed varies normally with a mean of this, so 150, plus the expected value of the coffee concentrate is 40. Hence, it's 190 milliliters. That is your mean. That's good. Now, we want to find the standard deviation, which, okay, we need to first find the variance of water, the coffee, which is variance of W plus F, which is the variance of W plus the variance of F, the coffee concentrate. Let's make this small and bring this over here. Okay, so the variance of water, we know that the standard deviation is this, so it's just the square root of it, so 6.3 squared. And the coffee concentrate, the variance is just 1.6 squared. Okay, and then if we want to find the standard deviation of SD of C, it's just going to be the square root of that expression, which is what? Let's do that calculator. So we want the square root of 6.3 squared, 1.6 squared. That gives us 6.5 milliliters. So that is your so that's the standard deviation, and that's the mean. That's it. That was not too bad. Very nice and easy. Kind of a common question in exams now. The special exams, this kind of question. So that's great. Find the probability that a long black coffee dispensed by the machine, so remember long black coffee is our C, dispensed by the machine overflows a 200 milliliter cup. Give your answer to correct the 3 decimal places. So we want the probability that the black long coffee, so your C value, must be greater, so it overflows the 200 milliliters cup, which is that. It's very easy, just use your calculator, it's only 1 mark, so I'm gonna copy that actually, and just go to probability distributions, normal CDF, so 200 to infinity. Well, we know that your standard deviation is 6.5. What am I doing? 6.5, and your mean we said was 190. Which is this, yeah? So 200 to infinity, 190, 6.5, we get this. So to 3 decimal places, that's going to give us 0.062. Is that right? So 1, 2, 3, yes, that's good. That's your answer. Next question. Suppose that the standard deviation of the volume of water dispensed by the machine can be adjusted, but the mean of the volume of water dispensed and the standard deviation of the volume of the coffee concentrate dispensed cannot be adjusted. Find the standard deviation of the volume of water dispensed that is needed for it to be only 1% chance of a long black coffee overflowing a 200 milliliter cup. Give your answer in milliliters, correct to 1 decimal place, correct to 2 decimal places. That's a lot. Wow. So what we're looking at is we want to find the standard deviation of the volume of water, so water. Okay, and what are we given here? We're given that the probability, it says that it's needed for there to be a 1 chance for a long black coffee, so coffee, to overflow, so to be greater than the 200, and we want, so there it's needed to be only 1, so 0.01. So if we want a 1% chance of a long black coffee overflowing it, we get this. Okay, so what do? Okay, let's pretty much do everything backwards. So what I'm going to do is, I know that the probability of C to be less or equal to 200 is going to be 0.99. Yes. And I'm just going to use, what is happening with me? Okay, let's think. So I'm going to convert this to Z. So Z is going to be 200 minus your mean value. Now, the mean's not going to change because they tell us, remember this mean, where's the mean? The mean of C is this. It's not going to change because they're only changing the standard deviation of the water dispensed. They're not changing the mean of the water dispensed. So it's still be 150 and plus 40, it's just 190. So still 190 minus 190 all over some value of the standard deviation of C, which is not anymore 6.5, so we call it that. And that is all equal to 0.99. And let's use our calculator to calculate that standard deviation. So we go to menu, we go to probability distributions, and we go to inverse normal. The area is 0.99, we said, and press OK. We get this, and this should equate to 10. So 200 minus 190 is 10 over O, which is our standard deviation. We want to solve answer, comma O. And we get this value of O. So let's write that down. So what we're saying, this O is the standard deviation of value of C is 4.2985. Let's make it okay. Now, remember how we said, okay, let's bring this to variance. So to get the variance of C, it's the square of that value. So 4.2985 squared. Yes. And we know from our original thing, we did to calculate the value of C using this formula. So we know that the variance of C is just equal to the variance of the water plus the variance of the F, which is the coffee concentrate. Yes? All right, so if this is 4.2985 squared, and we want to find the variance of the water, plus the variance of F is not going to change. It hasn't changed. So we said the variance of F is what? It was, coffee concentrate is 1.6. It was 1.6 squared. Let's write that down. 1.6 squared. And we want to calculate the variance of W. So this is our calculator. So, so this over here, squared, will be minus of 1.6 squared. And that over here gives us the variance of W. And to find the standard deviation of W, it's just going to be the square root of this. And this is your answer. So this is your standard deviation of water, the water dispense. So let's write that down. Your SD of water to 2 decimal places is 3.99 milliliters. That's it. Easy. Last question. Question 7. According to the medical records, the blood pressure of a general population of males aged 35 to 45 years is normally distributed with a mean of this and a standard deviation of 14. Researchers suggest that the male teachers have a higher blood pressure than the general population of males. To investigate this, a random sample of 49 male teachers from this age group was obtained and found to have a mean blood pressure of 133. So what had happened is it's actually greater than the normal mean. So we have to do a statistical test about this. State two hypotheses and perform a statistical test at 5 levels to determine if the male teachers belonging to the 35 to 45 years age of group have a higher blood pressure than the general population of males. Clearly state your conclusion with a reason. Easy. So first let's write the two hypotheses. So your null hypothesis, we're going to say that there's no change. So it's still 1 to 8, the basic 1 to 8. And the alternative hypothesis, we will say that there is, that the mean is actually greater than that 1 to 8. It's actually 1 3, so it's actually increased. So these are your two hypotheses. To determine if, what we need to do a statistical test, we're going to find the p-value. So the p-value is going to be the probability that your sample mean is going to be greater or equal to that 133, given that your mean null hypothesis, which is 1 to 8, and we'll calculate that. So we know that if we convert it to Z, so if we convert that to Z, it's going to be 133 minus 1 to 8, all divided by your standard deviation. But remember, your standard deviation is your S over root N. So what is our S? We know that the deviation is 14. And the square root, how many males do we get? We get 49 of them. So square root of 49 is just 7, which is just 2. So you're, okay, that's 2. Okay, and yeah, let's use our calculator to calculate the probability of this. So it's just 5 over 2. So 5 over 2, which is 2.5. So what we're going to do is go on menu, go to probability distribution, go to normal CDF. And we're saying this value over here to infinity. And again, we're using standard number distribution, so your mean is 0 and your standard deviation 1. Press OK, and we get this. So let's write that down. 0.0062. Okay, now let's think. If the p-value is less or equal your alpha value, so that 5%, which is in this case 0.05, then we reject the null hypothesis. If your p-value is greater than that 0.05, we accept the null hypothesis. Well, in this case, what do we know? This value is very, very small. It's less than that 0.05. So hence we want to say that p is less than less or equal to your 0.05. Hence, we reject your null hypothesis. So if we're rejecting this null hypothesis, we are saying that your actual mean value, it's true. So for teachers, their blood pressure is, yeah, we accept that. So for teachers at the ages of 35 to 45. So for teachers at the ages of 35 to 45 have, for teachers at the age of 35 to have likely, so have likely, we can say, yeah, have, wait, this is actually hard to write. So, we're rejecting the null hypothesis, we're rejecting the null hypothesis, so we're accepting, so accepting the alternative hypothesis where they actually do, from the statistical test, they do have a higher blood pressure from the actual mean, the average male. So for teachers at the age of 35, they do have a higher blood pressure than the mean, than the average. Yeah, average 35 to 45, pretty much. Yeah, I hope that makes sense. Done. Then find the 90% confidence interval for the mean blood pressure of all males aged 35 to 45 using a standard deviation of 14. Give your answer correct to the nearest integer. Very nice, 1 mark. Just use a calculator. So go calculator, go earn statistics, confidence intervals, and go to Z interval. We're going to go to stats. Okay, so we saw the mean is 14. We know that the sample mean, which was 133, we know that there was 49 individuals, and we want 90%. So 0.9. Press enter. Control enter. And we get our C lower and C upper, and we want it to the nearest integer. So let's write that down. So what do we get? We get 130. Oops. 130 to 136. That's it. That's the end of the exam. Thank you guys for watching. Please make sure to like and subscribe for more future videos. I hope you enjoyed this video and learned something through this video. Please make sure you share it with your friends, and I hope you have a great day, guys. Take care. Bye bye.